Hello, I'm Laura. We've covered dwell time in the first video of this series, and we've also covered how FixedUpdate solved our problem about calculating physics. This video assumes that you're already familiar with dwell time and fixed dwell time. So if you're not familiar with either of them, then you might want to check my previous videos, the links in the description. So you might be wondering, what problem does FixedUpdate have? Most of the cases, there's nothing wrong about using FixedUpdate. But there's a special case where we need some objects to have exactly the same time step on each frame, no matter whether the object is handled inside update or fixed update. Because using fixed update, the total fixed time step happening in one frame might be different from the update method. Let's say with fixed time step of 0.02 seconds, in a frame where the dwell time is 0.09 seconds, then the fixed update will be called 4 times. But here's the thing. The dwell time, or in other words, the actual total time step of the current frame is 0.09 seconds. But the total time step of fixed update of the current frame is 0.02 seconds times 4, which is 0.08 seconds. It's worth noting that the display refresh happened during the actual dwell time. So one of the cases where this might be a problem is when there's a display related method that depends on an object that is handled in fixed update. To be clear, here's an example. You have a character whose movement is handled by fixed update, and you have a camera that smoothly follows the character and the movement is handled by late update. If you're wondering what late update is, late update has the same dwell time with update method and also behaves exactly like update method, only that it is called after the update method. So it's pretty useful to utilize it to update our camera, since it's better to wait for any logic to be processed before actually rendering them. And then the reason the camera movement doesn't use fixed update is because it's generally not recommended to move the camera in fixed update, as it can limit the smoothness of the display, since the camera movement steps will be locked according to the fixed time step. And it would be such a waste when our frame rate is actually higher, as it could produce tighter intervals. As you can see here, when the frame rate is 60 frames per second, after a certain duration, when you could have updated 4 times, but instead you got only 3 calls. Sad. And remember that we're talking about a camera, meaning that it affects the whole look of the display and will effectively limit the actual frame rate of the whole game. So let's get back to our character and camera example. Since the camera follows the character, if we don't want to apply the camera movement smoothing, then we can just immediately apply the character's position in our camera. This way, there will be no jittering problem, since we effectively set our camera's position exactly according to our character without involving the dwell time. But the problem is, since the character is moving in fixed update, then even if we apply the camera movement inside late update, in the end, it's just the same as if we are moving the camera inside the fixed update. So let's forget about that idea and we'll try to use dwell time to move the camera instead of using fixed dwell time. Now, since the camera follows the character, to simplify the example, we can say that both of them are moving at the same speed. The only difference is that the character uses fixed dwell time, while the camera uses dwell time. If we try to simulate their movement each frame, then we will notice that whenever the display refreshes, there's always an inconsistent offset between the character's position and the camera's position. Remember what we are talking about, that the total duration of time steps in fixed update and in update are different. And now we can clearly see it using this offset. Let's see what the camera actually sees in the actual game display. And this, apparently, is causing a stuttering display, which is very annoying. And this is where we need to implement the Substep update. What is a Substep update? For those of you who are familiar with Unreal Engine, then you might also be familiar with substepping. In Unreal, instead of using a fixed time step, it uses Substep. This is something that is not available in Unity by default, but we can actually implement it. Since we already know what a fixed update is, there's only a slight difference with Substep update, but it's pretty impactful. In fixed update, we know that if there's a remainder between the data time and the total of the fixed data time, then the remainder will be accumulated into the next frame. But in Substep update, the remainder is not accumulated into the next frame, but instead, it calls the Substep update again with the modulus or the remaining time step as the time step of that Substep update. For example, with fixed time steps of 0.02 seconds, in a frame with a dwell time of 0.09 seconds, then Substep update will be called 5 times, since 0.09 divided by the fixed time step, which is 0.02, is 4, adding one more call using 0.01 seconds as the time step. Given this information, so technically, Substep update has more call count compared to the fixed update, but it is a very slight performance loss that it's really worth it to achieve the ideal camera smoothing. Let's go back to our example and try to simulate it again. This time, the character movement is not handled inside fixed update, but instead, it's handled inside Substep update. Let's implement the C# script using the concept of Substep that we were talking about. Now that we've implemented it, let's see the result. We can see here that both the character and the camera move at the same time step when the display refresh occurs. No more inconsistent offset that causes the stuttering. Finally, we can apply a camera movement that smoothly follows the character by lerping it. Now, we don't have to worry about different time steps since they are all having the same time step. Additionally, you can refactor it to extract it into a separate class called Substep MonoBehavior. This way, you can use this instead of an ordinary MonoBehavior whenever you want to implement a Substep update. For more advanced purposes, you can also create a singleton Substep handler to achieve a more parallel approach if you have more than one object using Substep update that interacts with each other. But actually, it's all up to you on how you want to refactor it. And that's it about Substep update. I hope you guys enjoy it. Leave a comment down below if you have any question or suggestion. Be sure to subscribe because it means a lot. Thank you very much and see you guys in the next video.